All right, so we're going to do basic graphs for sine and cosine waves with just a basic 5 points, and then we're going to do a little bit where we stretch or shrink the graph. So sine and cosine waves are called periodic functions because the wave can be repeated. I can go around the unit circle multiple times. I can go clockwise or counterclockwise. It creates a wave in the coordinate plane, and it's repeated. Because it's repeated, each repeat of the wave is called a period. So it says the smallest span over which the interval repeats is the function's period. For sine and cosine waves, it's one full wave. So from start to finish, and then I would repeat it if I got to the end. The other word we're going to want to know here is the amplitude. And the amplitude, the technical definition right here, half the distance between the maximum and minimum of the function. I'm going to show you guys that on the graph, but it's basically the height of the wave above or below the midline, and we'll get into that here in a second. Now, we're going to start and do the sine wave, just a basic sine of x, y equals sine of x, and I've got the unit circle pictured here, and I want to remind you the sine on the unit circle corresponds to the y-coordinate of each of these points. So I've got a unit circle, and it just has where the unit circle intersects the x and y axis. And I'm going to do a basic 5 points with this. And you're probably like, that's only 4 points, but here's what I'm going to do. For the radian measures, I'm going to use that when we graph this. This would be 0, so that'd be 1 point. This in radians would be at pi over 2 for your angle measure. This would be at pi. This would be at 3 pi over 2, and then I'm going to get my 5th point because I'm going to come back here and use 2 pi. So it's going to be this point twice to get a good idea of the sine wave. Okay, now for my table, the x-coordinate is going to be the radian measure, and the y-coordinate is going to be the sine of that measurement. So I'm picking these 5 points because if I do that, then my y values that I have to put on the graph are either 0, 1, or -1. So this will be easier to graph just doing this set of 5 points. So for the x values, I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi, those basic 5 points. Now to do the sine, and I just highlighted it on my little tiny unit circle here, so the sine of 0 is 0, pi over 2 is 1, at pi it's 0, at 3 pi over 2 it's -1, and then back around I'm at 0. If I kept going around the circle, then that pattern would just continually repeat, so that's what creates the wave. Now when you guys come up to the graph, I have marked pi, 2 pi, 3 pi, 4 pi, and then there's some space in between. So if I start at 0, this is 0, 0, if you guys look at the unit circle, directly between 0 and pi is that pi over 2, and so it's the same way on the graph. Here's 0, here's pi, right directly in the middle would be pi over 2. On the unit circle, if you look between pi and 2 pi, directly in the middle is 3 pi over 2. So I'm just going directly in the middle of pi and 2 pi. And if you just do that on the midlines, right in between, right directly in between, that'll be all your pi over 2's. So I'm just going to mark those on my graph really quickly, and this will help us draw the wave. So here, once around the circle, 0, 0, then at pi over 2, which would be right here, I'm up at 1, back to 0, then down to -1, and then back to 0. That is one full wave. So that's at 2 pi. Now, if I continued, if I went around the circle and I go again, now this would then be 5 pi over 2. If I kept going another pi over 2 here, then that next point would be up at 1. This would then be 3 pi. That would be back at 0. Go again. That would be 7 pi over 2. So back down to -1. And if I go around twice, that would be 4 pi, and I'm back to 0. You can also go in a negative direction, the clockwise around the unit circle. So I'm going to go backwards here. If I go negative pi over 2, right, that'd be right here. So negative pi over 2 would be at -1. Negative pi would be at 0. negative 3 pi over 2 would be at 1. And then negative 2 pi is back at 0. And we just repeat, so I could just keep going. Like if I kept going here, this would go negative 1, 0, 1, back to 0. And that creates your wave. And I'm just going to kind of ride through here with my wave. So you guys can see this. Now, I'm going to put some arrows at the end because that would continue, and then just talk about some critical information here. So, domain, this goes left and right forever, so negative infinity to infinity. The range, the first value, and you would touch it in multiple locations, but the first value you would touch would be negative 1. The last value you would touch would be positive 1. There's nothing above that, nothing below that. And we do have actual coordinate points there, so I'm going to use a bracket. So the range just stays between negative 1 and 1. Now the period I'm going to draw on here. So the period, you can measure this from different places on the graph. I usually just like to start with a vertical line on the y-axis, and I start there and I'll go through the wave. So the period is the time it takes to make one complete cycle through here, one complete wave. So I'm going up, I'm going down, I'm going back up, and if I'm at 2 pi, then I'm restarting that same wave. And I'm going to mark these off. It's every 2 pi here, and that goes in the positive and the negative direction. If I were to literally take a pair of scissors and cut this out, I could pick this up and slide it down to the next piece, and they would match up exactly. Same thing, I could just cut this out, slide it down, and they would match up exactly one wave for each of those. And you'll see from 0 to 2 pi, that's 2 pi. 2 pi to 4 pi, that's also 2 pi. Negative 2 pi to 0, that distance would be 2 pi. So that distance is what your period is, 2 pi to make one complete wave. Now the amplitude, and I'm going to grab a highlighter here real quick. So the very middle of these waves, sometimes called the midline, it would just be the x-axis for this graph, but the amplitude is just the height above that midline, so or below. So this goes up 1. If I go down, the wave goes down 1. So the amplitude is just going to be a distance of 1. Now your x-intercepts, this is a little weird, but if you start looking at the graph, it intersects the x-axis in multiple locations. So if I'm going here like negative 2 pi, negative pi, 0 pi, 2 pi, 3 pi. So I'm just going to list a couple of these, like negative 2 pi, negative pi, 0 pi, 2 pi, 3 pi. Keeps going both directions for negative 3, negative 4. Now, because it intersects, here I'm going to write it over here, in multiple locations. It's just like 1, 2, 3, 4, 5, keep going. We call this n pi, and then what we have to do is define n real quick, and I'm going to say n is an integer. So integer is a nice plain number, but it could be positive or negative, and because the graph is continuous, goes all the way to the left and right forever, it could be any negative integer or any positive integer as well. That's your sine function. Okay, so I'm going to do those same 5 points, but this time we're going to do the cosine function. So the cosine, if you remember, if you're looking at your unit circle, is the x-coordinates. So that's what I'm going to focus on. And I'm going to grab those same special 5 points that make it easier for us to graph. So I got 0, pi over 2, pi, 3 pi over 2. That's 4 points I'm going to talk about. And then when I'm back around, I'm going to repeat this point. That gives me the 5th point, and that will be the end of the cycle for the wave, and then it will start over. So, again, I'm just using that exact same table, those 5 points. And I'm just doing this because 1 and 0 are nice numbers for us to graph. That's why I'm choosing those instead of some of the other points around the unit circle. Now, here, I've got my angle measure, and then my y-coordinate is going to be the cosine of theta. Now, the cosine of each of these angles is going to be the x-coordinate of the point in the unit circle. So just be careful with that. So x-coordinate I'm going to look in to fill in the y-coordinate on the coordinate plane graph. So the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi, negative 1. 3 pi over 2 is 0. and then we are back at 1. So there's the cycle for a cosine. So again, right in between each of these marks will be your pi over 2's. So I'm just going to put those in the graph because they're not really marked there to help myself go through here. So this is going to start, the sine always starts at the origin, the cosine is going to start 0, 1. Then I'm going to go back down to 0, -1, 0, back to 1. That is one complete wave. And I can just keep repeating that. If I keep going around the unit circle, the next, so I'm here, the next cosine 0, the next cosine -1, the next cosine 0, and then back around, we're at 1. It just repeats. I can go in the negative direction. So here I'm at 1. If I go backwards, I'm 0, then I'm -1 here, then I would be back to 0, and then back here I would be at +1. So you can just back it up. And that pattern continues. That's what creates the wave. So if I come through here with my lovely marker, we're just going to kind of draw on this. Mean difference, an easy way to tell the sine from the cosine. The sine goes through 0, 0 through the origin. The cosine is going to go through a point on the the y-axis. So in that case, 0, 1. There's your cosine. Now, domain, totally the same, -infinity to infinity. Range, totally the same. The bottom is -1, the top is 1, nothing above or below. Now, I'm going to line the period up here so you can see. From here, I start at 0, 1, go down, come back up, and then I restart the wave here. And you'll notice it took me to get to 2 pi to restart that wave. So this actually, it looks different in terms of where it's placed, but the period for the cosine function is also 2 pi, just cosine of x. The amplitude is the same. The middle of the graph here again would be the x-axis. I'd go up 1 to get to the top, or I'd go down 1 to get to the bottom of the wave, so the amplitude is 1. Now the x-intercepts here, this is a little bit weird. If you want to look at the unit circle here, it's 0. When I'm right here, I'd be at pi over 2. And right here again, I'd be at 3 pi over 2. So it's on these pi over 2's is where you're going to hit the x-axis. If you keep going here, this would be 5 pi over 2. This is 6 pi over 2, which is 3. This would be 7 pi over 2. This would be 8 pi over 2, which is where we're getting the force. So if you notice this, and this goes in the negative direction as well, these are all odd numbers. So like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and ... So the way we write this in general is n pi over 2, but if you notice, this is 1, 3, 5, 7, the next one would be 9. N has to be an odd number, so we have odd integer. So because it intersects the x-axis in multiple places, that's how we have to write it. All right, and I'm just going to have us just do one quick kind of a modification to a sine or a cosine function here, and that's a vertical scale change. This is going to change the amplitude or the height of the wave for your graph. And in an equation, I'm going to say changes the amplitude. What you're looking for is you're going to multiply outside, and I'll kind of explain what I mean by that by giving you guys an example. Outside the function. Okay, so like something, I mean outside like in front of it. So something like this, like 10 sine x, or y equals 1/3 cosine x. This number out in front, the 10 here, or the little 1/3 I'm just using as my example, those are going to modify the height of the wave. The number is larger than 1, that's going to cause the wave to be taller, that's going to be a stretch, and if the value in front here is between 0 and 1, this is going to cause what we call a shrink. It's going to kind of flatten, I spelled that wrong, shrink. That's going to flatten your graph out. So here's how this works. Excuse me. Let me write those 5 points, right? Those 5 easy points that we did on the graph. This one is going to be a sine, so I'm going to focus on the y coordinates around my unit circle. All right, so I have 0, the pi over 2, pi, 3 pi over 2, sorry, I'm writing a little bit small here, and then 2 pi. Now, normal sine function, we would have the points I have highlighted here. What we're going to do is we're going to multiply that by 3. So that's what I'm going to do to my sine values here. So the sine of 0 is 0. If I multiply that by 3, that's going to stay 0. The sine of pi over 2 is 1, but 3 times that would make this 3. 3 times the sine here would be 3 times 0, so this is going to stay 0. And then when I'm at 3 pi over 2, my sine is -1. If I multiply that by 3, that's going to be -3, and then we're back at 0. So our table would be 0, 3, 0, -3, 0. All this is going to do is change the height of your wave. So I'm going to start 0, 0, then at pi over 2, right in the middle here, up at 3, 0 at pi, 3 pi over 2, I'd be at -3, and then back to 0. And we just repeat. So the next one would be 3, then we'd be at 0, then we'd be at -3, then we'd be back at 0. We can go in the negative direction right here. I would back up, this would be -3, 0, 3, 0. So the only thing that changes here, this is going to change the amplitude, and it would also change the range of your function. It does not change the domain. So I'm just going to jot down the two things that changes, something like that. My amplitude, the height of the wave here above the midline. The midline for this graph, again, is going to be the x-axis. So the height of that wave is just 3. And you'll notice that it's going to match that number out in front. And then the other thing it changes is the range. So now the lowest point is -3, the highest point is +3. And I do have points there, so I'm going to use brackets. So this goes between 3 and -3 for your range. Okay, for part B here, do me a quick favor, because it'll make it fit on the graph better. I'm going to change these 2 and -2 on the y-axis to be 1 and -1. That'll make it better to do. If I'm doing cosine, I want to focus on the x-coordinates around the unit circle. Those are representing the cosine of that angle measure. And as I go there, again, I'm going to try to write this kind of small. So 0, pi over 2, pi, 3 pi over 2, and 2 pi, those 5 points. Now, I'm going to take and multiply by 1/2. So my cosine of 0 is 1. If I do half of that, well, then that would be 1/2. Now, if I do the cosine of pi over 2, that's 0. So 1/2 times 0 is still going to be 0. If I do the cosine of pi, that's -1. If I do half of that, that would be -1/2. And then if I'm at 3 pi over 2, cosine there is 0. If I multiply that by 1/2, that's going to stay 0, and then we're back around. So I have 1/2, I have 0, -1/2, 0, and then the cycle starts over. So on the graph here, we're going to start up at 1/2. And remember, I altered the y-axis, so this would be 1/2 and this would be 1. At pi over 2, I'm at 0. At pi, I'm at -1. At 3 pi over 2, I'm back to 0. And at 2 pi, I am back, I'm sorry, this is -1/2, this is +1/2. And then the cycle would repeat. So then back to 0, -1/2, 0, back to 1/2. I can go back it up the other direction. So I was at 1/2. Backwards, we're going to go 0, -1/2, 0, 1/2. And I'm going to just wave through there. And then these graphs, these waves, can go on repeating that pattern infinitely. Okay, now here, the two things that would be altered by that 1/2. The amplitude is the height of the wave. So here, the x-axis is the midline again. So that's just going to go up 1/2 or down 1/2. And then my range here would be -1/2 to 1/2. And I do have one more. If you want to try this on your own, you could just mute this. This is 4 times the cosine of x. So for my cosines here, I'm going to make sure I use the x-coordinates. And this is 4 times that, so it's just going to multiply each of these x coordinates by 4. If I multiply 0 by anything, it's going to stay 0. So the cosine never starts at the origin. The cosine's going to start up at the top of the wave, which is going to be 4 here. In the middle, it goes to 0, and then it goes to the bottom of the wave, which would be -4. Back to 0, back to the top of the wave. That is one full iteration. Next, I'd go back to 0, down to the bottom, back to 0, up to the top. I can go negatively. If I'm at the top, I go to 0, and then I go to the bottom. And then I go to 0, and then I go to the top. And then that just repeats. So then here, so you guys can see this, this would be 4 times the cosine of x. And that's it. The amplitude there would be 4, and the range would be -4 to 4.